A bombshell just dropped on the astronomical community, but it wasn't from space. While the West's most powerful telescopes were blind, Chinese observatories released crystal-clear images of the interstellar comet 3I Atlas. This isn't just about a new comet, it's about a seismic shift in who controls our view of the cosmos. This sudden pivot in the observational balance is stirring more than scientific curiosity. It may signal a new era in how we monitor these alien visitors. Let's explore this together.
Strange composition.
What if a visitor from another star system was a complete chemical stranger? That's exactly what we're seeing with 3I Atlas. This object is unlike anything that originated in our solar system. Observations so far have revealed a bizarre chemical fingerprint. Its coma, the gassy envelope around its nucleus, is dominated by carbon dioxide emissions, with a CO2 to water ratio far higher than any comet we've ever seen. Data from the James Webb Space Telescope confirm this, showing a CO2-rich coma with only trace amounts of water. For comparison, a typical solar system comet might have a CO2 to water ratio of around 10%, but initial findings for 3I Atlas hint at something dramatically different. This composition tells a story. As explained by cometary scientists like Martin Cordner, such a high abundance of CO2 suggests the object formed in an incredibly cold region of its home star system, a place far colder than our own Kuiper Belt where even carbon dioxide gas freezes solid. The presence of irradiated ices and complex organics further deepens the mystery, suggesting its surface was battered by high-energy cosmic rays for millions of years as it traveled through the interstellar void. This isn't just a slight variation, it challenges our fundamental models of planet formation, which are almost entirely based on the architecture of our own solar system.
Telescopes go dark.
But what happens when our best eyes on the sky suddenly close right as this once-in-a-lifetime visitor is putting on its best show? This isn't a hypothetical fear, it's the reality that just unfolded. Major observatories like the Hubble Space Telescope, the JWST, and the European Southern Observatory's Very Large Telescope are the workhorses of modern astronomy. They provided the critical data that shaped our initial understanding of 3I Atlas. But these are incredibly complex machines. In mid-2024, Hubble had to switch to a single gyro mode, a necessary fix that nonetheless impacts its efficiency and scheduling flexibility. The VLT's four main telescopes periodically go offline for the recoding of their massive 8.2-meter primary mirrors, a delicate process that can take a telescope out of commission for weeks at a time. Even the JWST has faced challenges with its instruments. The transcript suggests several of these key Western telescopes went offline just as the comet's activity was evolving, creating a critical data gap. This isn't just bad luck, it exposes a systemic vulnerability in a highly centralized system, a single point of failure that can blind us at the worst possible moment.
China steps in.
Nature abhors a vacuum, and so does 21st century science. Into this observational gap, a new power has stepped in. China. Over the past 2 decades, China has invested massively in its astronomical capabilities, a strategic push outlined in its long-term science and technology development plans. The images of 3I Atlas didn't come from old equipment. They came from facilities like the Purple Mountain Observatory and the Xinglong Observatory, equipped with modern wide-field survey telescopes. These systems are capturing both the comet's detailed structure and the background star fields with stunning clarity. This capability is set to explode with the launch of the Zhangtian Space Telescope, a 2-meter observatory with a field of view 300 times larger than Hubble's, capable of surveying 40% of the entire sky over its 10-year mission. At a time when Western facilities are dark, observers in China are providing fresh frames of the coma and tail structures. This isn't just about filling a data gap, it's a strategic move that gives them a window to exercise scientific leadership. They have seized a historic opportunity, demonstrating that their long-term investment in astronomical infrastructure is now paying off on the world stage.
Data controls narrative.
Here's what really matters. In science, the person with the data writes the first draft of history. By capturing and publishing the first high-quality images of 3I Atlas during this critical window, Chinese teams will inevitably shape the scientific narrative. These initial observations become the reference points for all subsequent research. Think back to 1995, when Michel Mayor and Didier Queloz announced the discovery of 51 Pegasi b. Their data, showing a massive planet orbiting its star in just over 4 days, created the hot Jupiter category and dominated exoplanet theories for years. Similarly, the Chinese images might be the first to identify key features in 3I Atlas, setting the agenda for the entire global community. Their interpretations, published rapidly on preprint servers like Arxiv, will gain significant mindshare before the formal peer review process is even complete. In a scientific ecosystem where reputation and early access are paramount, this gives Chinese teams a powerful boost, allowing them to take the lead on developing the first credible models of this alien object's behavior and origins.
Data sovereignty.
This brings up a bigger, more complex issue. Who owns the data from another star system? For decades, Western astronomy, particularly NASA, has championed open data through archives like the Planetary Data System. This democratic approach allows any researcher, anywhere, to download and analyze raw data, fostering independent verification. However, this is not the only model. The European Southern Observatory often has a 1-year proprietary period, giving the original observing team exclusive access to their hard-won data. As China's infrastructure grows, it can choose its own path. Data becomes a tool of soft power. If institutions like the National Astronomical Observatories of China control access to their 3I Atlas data, it could create data silos, complicating the creation of a complete global picture of the comet. The decision to release the raw FITS files, the standard format for astronomical data, complete with vital metadata, becomes a strategic choice that impacts not just science, but scientific diplomacy and the very culture of international collaboration.
National prestige.
Let's be clear, observing the cosmos is about discovery, but it's also about power. Space science is deeply intertwined with national pride and global influence. China has long used its space program to showcase its technological prowess. The Chang'e 5 mission in 2020 returned 1,731 grams of lunar material to Earth, the first sample return in over 44 years, a massive prestige victory. Releasing key images of a rare interstellar wanderer like 3I Atlas, especially when others cannot, is an equivalent statement in deep space science. The media narrative practically writes itself. China steps up when others falter. This resonates far beyond academic circles, bolstering national prestige and justifying massive government budgets for science and technology, creating a self-reinforcing cycle of investment and achievement. It reframes the 21st century space race as a contest not just of exploration, but of knowledge generation, positioning China as a leader in a frontier domain previously dominated by the West.
Infrastructure fragility.
Ultimately, the 3I/Atlas incident exposes a fundamental crack in the foundation of global astronomy. For decades, the field has been shaped by a heavy reliance on just a handful of powerful, Western-funded flagship observatories, many of which are, geographically concentrated in places like Hawaii and Chile. But honestly, this model is fragile. This event serves as a stark reminder that our global network for monitoring the sky is just not robust enough. It really highlights the urgent need for diversification and support for projects like the Vera C. Rubin Observatory in Chile. Once operational, its 8.4-meter mirror and 3,200-megapixel camera will conduct the legacy survey of space and time, scanning the entire visible sky every few nights. This kind of continuous watch is a direct answer to the problem of missing transient events. The incident also underscores the importance of geographically distributed networks, like the Square-Kilometer Array, ensuring that no single point of failure, be it technical, political, or weather-related, can blind humanity to a critical cosmic event.
Verification questions.
New data is thrilling, but it arrives with a critical question. Can we trust it completely? The scientific process is built on verification, and integrating the Chinese data on 3I Atlas isn't simple. Are the new images calibrated in a way that is fully compatible with previous data? To answer that, the global community needs the raw FITS files and all associated calibration frames, the darks, biases, and flat fields required to remove instrument signatures. Without these, it's impossible to perform accurate photometry, the measurement of the comet's brightness, to see how its activity is changing over time. Furthermore, high-precision astrometry, or the exact measurement of the comet's position against background stars referenced by the Gaia catalog, is crucial. This data is needed to refine 3I Atlas's hyperbolic orbit and search for tiny non-gravitational forces caused by outgassing. Full transparency, including sharing data reduction pipelines, is the only way for the results to be independently replicated and universally accepted by the scientific community.
What the images reveal.
So, what could these Chinese images of 3I Atlas actually show us? They are far more than just snapshots, they are dense with physical clues. Astronomers like David Jewett at UCLA, who co-discovered the Kuiper Belt, would meticulously analyze the coma for structure. A faint jet, perhaps only a few arcseconds long, could reveal the spin axis of the nucleus and point to a specific active region. By measuring its surface brightness, one could estimate the dust production rate in kilograms per second and compare it to well-studied comets like 67P Churyumov-Gerasimenko. The transcript suggests that some releases show brightness falling off more rapidly in certain sectors, hinting at asymmetric outgassing. Most excitingly, a rapid sequence of images might capture a fragmentation event. If the nucleus were to split, as comet C 2019Y4 did, these observations might be the only record of it happening, providing invaluable data on the structural integrity and tensile strength of an object from another star system.
Global wake-up call.
Bottom line, this event is a shock to the system of global astronomy. It's a wake-up call on multiple fronts. First, it forces a reckoning with the fragility of our observational infrastructure. It will likely accelerate pushes for more distributed networks and formalize coordination through frameworks similar to the International Asteroid Warning Network. Major observatories will likely reevaluate how target of opportunity time is allocated to ensure that high-priority interstellar objects get immediate coordinated follow-up. Second, it recalibrates the geopolitical landscape of space science, forcing Western institutions to forge new alliances and advocate for more resilient, internationally managed observatories. Finally, it shines a light on the changing nature of discovery itself. It's becoming less about a lone genius at an eyepiece and more about managing vast, complex, and sometimes fragile global systems of technology, data, and collaboration. The 3I Atlas event is a powerful case study in this new scientific reality.
What do you think this shift means for the future of astronomy? Is this increased competition a good thing for science, or does it risk fragmenting our global community? Let us know your thoughts in the comments below. We want to hear from you. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Thank you for watching Future Facts.
15 billion miles from Earth, NASA's ancient Voyager 1 spacecraft just detected something that shouldn't exist. 305 massive objects moving in perfect formation through the darkness of interstellar space. These aren't planets, asteroids, or comets. They're something else entirely, gliding through the void with deliberate precision that defies every law of physics we understand. The objects appeared to communicate with each other through rhythmic pulses, maintained impossible trajectories, and displayed behaviors that left NASA scientists questioning everything they thought they knew about the universe beyond our solar system. The Lonely Pioneer's shocking discovery. What if humanity's most distant explorer just stumbled upon proof that we're not alone in the universe? Voyager 1, launched in 1977 when Star Wars first hit theaters, has become something truly remarkable. The first human-made object to reach interstellar space, the region between stars where our sun's influence fades away. This car-sized spacecraft has traveled over 15 billion miles from Earth, so far that radio signals moving at light speed take 22 hours to reach it. When engineers send a command, they wait almost 2 full days for a response. The spacecraft carries instruments that seem ancient by today's standards: magnetometers, cosmic ray detectors, and plasma wave sensors designed with 1970s technology. What makes Voyager's survival incredible is that it wasn't built to last this long. Engineers expected it to function until maybe the early 2000s, yet here we are in 2025, and Voyager continues whispering back to us across the stars. Its nuclear power source, running on decaying plutonium, was supposed to have died decades ago. The spacecraft also carries the famous Golden Record, a time capsule of Earth sounds, music, and greetings meant as a message to any intelligence that might find it. Little did we know this cosmic hello might have already attracted attention much sooner than anyone expected. The first anomalous signal. In the endless stream of data flowing back from Voyager, something appeared that would change everything. A tiny flicker that seemed like nothing at first. Space is full of dust and radiation, and occasional weird readings are normal, so NASA's Jet Propulsion Laboratory initially dismissed it as background noise. Suzanne Susie Dodd, one of the mission specialists who first noticed the anomaly, described it as like shouting into a canyon for decades and finally something shouts back. The reading was faint, just a slight reflection of light picked up by Voyager's sensors that seemed too minor to investigate further. But then something changed. This wasn't just a particle floating randomly through space. The object moved in a way that caught everyone's attention. It curved, accelerated, and didn't tumble chaotically like debris would. Instead, it glided smoothly, as if under intelligent control. When Voyager's plasma sensors registered a shift that seemed deliberate and focused, the team realized this wasn't background noise. Jonathan D.A. Clark observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock, suggesting it had intention. That observation changed everything, because in the physics of space, things don't just move with purpose unless something is making them move that way. Ruling out natural explanations. When something unusual appears in space, scientists have a standard playbook. They systematically check all familiar possibilities. Is it a small moon, distant comet, or new asteroid? One by one, the team worked through these options, and one by one, each possibility fell away. This object wasn't a planet, far too small. Not a comet either. There was no tail, no ice trail, no heat signature. It didn't glow like a star, and gravitational lensing couldn't explain what they were seeing. Even space dust was ruled out because dust doesn't suddenly change direction mid-flight. Dr. Nicola Fox at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known models. What makes space objects usually predictable is physics. Everything moves according to known patterns and forces. But this object broke those rules. Its path bent in ways that didn't match any known orbital behavior, with no drift or decay expected from natural objects. The team was forced to admit something difficult. What they were seeing wasn't just unknown, it was unnatural. The movement pattern suggested intelligence, or at least design. The object seemed to be moving with purpose on a specific trajectory that couldn't be explained by gravity, solar wind, or any other forces that typically influence objects in space. It was as if something was guiding it, adjusting its course with precision. Confirmation from Voyager 2. Just as scientists were trying to make sense of what Voyager 1 had detected, something extraordinary happened that transformed this curious anomaly into something far more significant. Voyager 2, the twin spacecraft following a completely different path millions of miles away, detected something eerily similar. The same kind of magnetic fluctuation, the same kind of pulse, a matching signal signature that changed everything. This was the turning point in the investigation. Two different probes, two separate instruments picking up nearly identical phenomena ruled out the possibility of internal error. It wasn't a software glitch or sensor malfunction on Voyager 1. Whatever this was, it was real and happening in multiple directions of space. ESA analyst Mark Fontaine compared it to two lighthouses both catching a flash of something passing between them. This cross-confirmation gave the anomaly weight and credibility. It wasn't noise. It wasn't Voyager acting up. It was a real, coordinated phenomenon happening in the space between stars. The team now had evidence that couldn't be dismissed. Something was moving through the region where both Voyagers were traveling. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation used only for phenomena that don't fit within our current scientific understanding. The event was real, the math was consistent, the movement appeared deliberate, and nobody knew what to make of it. The formation of 305 objects. When the team analyzed the full telemetry logs, what they discovered sent chills down their spines. This wasn't just one or two anomalies moving through space. There were 305 objects, all moving together in formation. Each one glided past Voyager 1 in what appeared to be a choreographed arc, smooth, precise, and coordinated. These weren't debris fragments scattered randomly. There was no heat signature, no tails, no signs of decay you'd expect from natural objects. Most striking of all, the reading showed rhythmic pulses echoing through the plasma waves, the kind of pattern you'd expect from something engineered, not formed by chance. The 305 objects weren't simply passing through randomly. They were moving together as a unit, maintaining relative positions to each other in a way that suggested organization and purpose. In space, groups of objects tend to spread out over time due to slight differences in velocity and gravitational influences. Yet these objects maintained their positions relative to each other with precision that seemed impossible without some form of control or guidance. Some scientists compared it to watching a flock of birds or school of fish, except these were in the vacuum of space where such coordinated movement shouldn't be possible without technology. What made this discovery particularly unsettling was the scale. 305 objects all moving with the same unnatural characteristics, all passing by Voyager at roughly the same time suggested something far more significant was happening in interstellar space. The language of rhythmic pulses. As scientists examined the data more closely, something truly strange appeared in the signals. Patterns of repetition that weren't the kind you'd expect from stars or cosmic background radiation, but steady, measured sequences that suggested communication or control systems. The plasma wave pulses coming from these 305 objects had loops, sequences, and structures that hinted at something more complex than random cosmic noise. They didn't just pass by Voyager, they seemed to broadcast signals as if they were pinging, scanning, or talking to each other. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or a system. The idea was shocking, but increasingly difficult to ignore. These objects weren't moving in a chaotic swarm, but in an ordered, intentional formation similar to how programmed drones might operate. Some experts went further in their assessment. ESA's Eric Lousy suggested this could be some sort of probe network, though he was quickly asked to stop speculating publicly. Even typically, grounded scientists like Neil deGrasse Tyson admitted there were patterns in that data that aren't random. To be absolutely certain they weren't seeing a glitch, the team activated one of Voyager's oldest subsystems, a backup telemetry channel that hadn't been used since the 1990s. The backup system confirmed everything the primary systems had detected. The signals, the paths, the formations, all identical readings sent through a completely different channel. The implications were staggering. Impossible propulsion systems. Voyager's readings didn't just capture the presence of the objects, they revealed how these mysterious entities moved through space, and this is where things got even stranger. There were no engine flares, no ion trails, no signs of any propulsion system we would recognize, yet Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally. Some were moving faster than anything humans have ever launched. According to the data, some speeds even exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't objects drifting passively through space. They were powered somehow, moving with purpose and incredible speed. Dr. Eric J. Zernstein from Princeton noted that they're not floating through space, they're navigating it. But what worried him more was their path. These objects didn't come near Earth or show any interest in our solar system. They passed by at a calculated distance as if deliberately avoiding us or simply had no reason to stop. The method of propulsion remained a complete mystery. Nothing in our current technology even comes close to explaining how these objects move. They appeared to be manipulating space itself, creating waves or ripples in the fabric of space-time that allowed them to glide forward without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure, as if these objects were using the medium of space itself to move. Earth detects the echoes. While NASA focused on Voyager's raw data, something odd started happening back on Earth that would make this mystery even more compelling. Across various corners of the globe, amateur radio operators, some just hobbyists with backyard setups, began reporting strange activity. They were picking up weak, irregular pulses, a kind of rhythmic static that didn't match any known terrestrial source. At first, it seemed unrelated, just coincidence. After all, radio interference happens all the time. But then the reports were time-stamped and compared. They aligned almost perfectly with the same hours that Voyager had recorded its most intense plasma anomalies. These weren't professional observatories or part of any official deep space listening effort. Most of these setups were built from spare parts, tuned to catch meteor scatter, amateur satellites, or solar flare chatter. Yet somehow they were detecting faint echoes of what Voyager had picked up billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in the ionosphere. This raised a troubling question. Was this bleed-through accidental, or was it purposeful? Was something out there testing Earth's listening capability, dropping breadcrumbs for us to follow? That uncertainty kicked off a quiet storm behind the scenes. NASA began encrypting parts of its deep space telemetry feeds, and intelligence agencies took notice, beginning discussions about electromagnetic security and whether these signals could be weaponized or intercepted. The machine awakens. Then, as if things weren't strange enough, Voyager itself started acting differently in ways that defied explanation. Its guidance system, called the AACS, Attitude and Articulation Control System, began misbehaving, not catastrophically like a crash. But it started routing data through old, long unused systems, almost like it was bypassing its own core software. At first, engineers thought it was a bug. After all, this is a 47-year-old spacecraft running on code older than most people analyzing it. But the deeper they looked, the weirder it got. Voyager wasn't failing. It was reconfiguring itself, reactivating memory segments that hadn't been touched in decades, rerouting its telemetry in ways that were never programmed. Then came the kicker. This behavior began right after one of the magnetic pulses from the passing objects. Could that burst have flipped a bit of memory? Could it have triggered some dormant function buried deep inside Voyager's ancient architecture? What engineers found was both promising and terrifying. The machine was stable, the instruments were fine, but the new behaviors weren't going away. Whatever was causing them, it wasn't internal decay or software corruption. Voyager had touched something, or something had touched Voyager, and the spacecraft was different now. To understand what was happening, engineers had to dig deep, literally opening dusty file cabinets at NASA's Jet Propulsion Lab. Most of Voyager's software was written in early assembly language, with some instructions existing only as notes in 1970s paper manuals. Part of something bigger. As scientists continued analyzing the strange signals pulsing through Voyager's instruments, a new and even more extraordinary idea began to take shape. Among the plasma wave readings, certain patterns stood out. Pulses that didn't behave like natural energy bursts but looked structured, measured, and intentional. Then someone noticed something else. The waveforms resembled quantum oscillations used in modern quantum entanglement experiments. These are the same kinds of signals researchers use on Earth to transmit information between particles separated by distance. It was subtle but undeniable, opening the door to a possibility no one had considered before. What if Voyager wasn't just recording random events in deep space? What if it had become part of something bigger? Maybe the 305 objects weren't just flying by. Maybe they were transmitting, broadcasting data through the interstellar medium using methods we don't yet understand. By pure chance, or maybe by design, Voyager was in the right place at the right time, with the right kind of analog sensors to pick it up. The signals didn't behave like random noise. They repeated, they looped, they followed harmonic intervals that looked eerily close to what you'd expect from encoded information. Something deliberately packed with meaning. Voyager, being such an old machine, might actually be the perfect listener. Modern probes are too noisy, filled with high-frequency electronics constantly transmitting and receiving chatter. But Voyager is slow, quiet, and analog. It has no clutter, no broadband digital static. It is, in a sense, the perfect ear in a cosmic concert hall, and being far outside the solar system, it's free from Earth's electromagnetic interference, just out there in the dark, listening like a perfect cosmic microphone. The mystery of Voyager's impossible encounter with 305 coordinated objects challenges everything we thought we knew about the emptiness of space. Whether these entities represent advanced technology from an unknown civilization, or natural phenomena operating by rules we haven't discovered, one thing is certain: the universe is far stranger and more populated than we ever imagined. As Voyager continues its eternal journey through the cosmos, it carries with it the possibility that humanity has just received its first glimpse of intelligence beyond Earth. What do you think these mysterious objects really are? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending space discoveries. Until next time, keep looking up. A massive visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, has astronomers worldwide both fascinated and honestly a bit terrified. Officially confirmed as the third known interstellar object, it carries an eerie potential. Is this colossal traveler a natural body, or might it be, an alien ship? Recent NASA data has sent ripples of fear and fascination through the scientific community, questioning everything we know about visitors from the stars. The breaking discovery. The discovery of 3Y Atlas marked a historic moment in astronomy, revealing a visitor unlike any seen before. Detected moving at an extraordinary velocity exceeding typical interstellar speeds, it challenged existing models of natural celestial object behavior patterns. NASA's advanced telescopes captured data suggesting anomalous properties, including unnatural acceleration patterns and an unusual trajectory that frankly defies conventional gravitational explanations. Researchers like Dr. Amir Siraj from Harvard University have highlighted these deviations as potential indicators of advanced propulsion systems, setting off widespread debate about the object's true nature among the global scientific community. The stunning size of 3Y Atlas far exceeds earlier interstellar discoveries, measuring approximately 10 to 15 kilometers in diameter, and igniting serious discussions about whether we are observing a spacecraft rather than a natural cosmic wanderer. From initial detection through detailed spectroscopic analysis, the international scientific community continues grappling with extraordinary possibilities ranging from exotic comet composition to genuine extraterrestrial technology. The implications of either conclusion would fundamentally alter humanity's understanding of our place in the cosmos and the nature of interstellar space. The discovery story. The remarkable story of 3I Atlas begins with its initial detection by the Asteroid Terrestrial Impact Last Alert System in early 2025, when automated survey algorithms flagged an object moving with unprecedented velocity characteristics. Astronomers quickly realized its trajectory was hyperbolic rather than elliptical, definitively confirming its interstellar origin from beyond our solar system boundaries. Its enormous size, estimated to be several kilometers across, dramatically dwarfed the infamous Oumuamua and 2I Borisov, making it by far the largest confirmed interstellar visitor discovered to date. Dr. Robert Warwick, who previously discovered Oumuamua at the University of Hawaii, coordinated initial observational campaigns revealing mysterious activity patterns indicative of possible artificial influence or control mechanisms. The object's calculated path through our solar system appeared to be deliberately planned, with intriguing timing and orbital alignments that prompted intensive scrutiny from major observatories worldwide. Global astronomical networks mobilized for an unprecedented international data-gathering campaign, dedicating thousands of observation hours to studying every measurable aspect of the object's behavior, composition, and structural characteristics before it passes beyond detection range. A stranger in our midst. As 3I Atlas traverses our solar system, its extraordinary properties consistently challenge natural explanations proposed by conventional astrophysics models. The object exhibits complex outgassing patterns inconsistent with typical cometary activity, suggesting an internal energy source actively controlling its emission characteristics rather than passive solar heating. Advanced spectroscopic data reveals a surface composition featuring unusual metallic elements and compounds not typically found in natural asteroids or comets, sparking intense debate about whether it represents an artificial construct. Astrophysicist Dr. Marco Micheli from the European Space Agency has pointed out the object's highly reflective surface properties and precisely controlled thermal emissions as potential evidence of technological design and manufacturing. Most puzzling is the object's demonstrated ability to withstand intense cosmic radiation and extreme temperature variations without apparent structural disintegration or expected material degradation. These collectively puzzling characteristics make 3I Atlas a prime candidate in humanity's ongoing search for evidence of extraterrestrial spacecraft, fundamentally transforming how scientists approach the study of interstellar objects and their potential origins. The mounting anomalies continue defying conventional astronomical explanations while supporting increasingly exotic hypotheses. The predecessors. 3I Atlas follows in the cosmic wake of two notable predecessors that have, really expanded our understanding of interstellar visitors. Oumuamua, the first confirmed interstellar object sighted in October 2017, and Comet Borisov, observed in August 2019. Each of these brought unique mysteries that, honestly, challenged established astrophysical models. Oumuamua's extremely elongated, cigar-like form and its completely unexplained acceleration away from the sun-puzzled experts around the world, while Borisov displayed more conventional cometary traits including visible outgassing and typical orbital mechanics. NASA researchers, including Dr. Karen Meach from the University of Hawaii's Institute for Astronomy, have emphasized just how important it is to compare these objects systematically to really understand the true diversity of interstellar visitors entering our solar system. Their cumulative comparative studies suggest a broad spectrum of both natural and potentially artificial objects traversing our galactic neighborhood, hinting at a far more complex and dynamic composition of the interstellar environment than scientists previously conceived. The sequential arrival of 3 on Atlas has really intensified international calls for establishing dedicated interstellar monitoring programs, capable of detecting and tracking future visitors with enough advance warning for detailed study. The cosmic journey. Traveling at incredible velocity with a definitively hyperbolic escape trajectory, 3I Atlas's epic journey from the depths of interstellar space really captures the imagination of scientists and space enthusiasts worldwide. The massive object appears to have originated millions, possibly even billions of years ago in a distant stellar system, and then embarked on this extraordinary voyage spanning both familiar and unfamiliar regions of our galaxy. NASA's Jet Propulsion Laboratory continues to support sophisticated computer simulations designed to understand how such enormous objects could, successfully traverse vast interstellar distances while maintaining structural integrity against all kinds of cosmic hazards. Dr. Alessandro Morbidelli's groundbreaking work in astrophysical dynamics specifically highlights the numerous challenges faced by such ancient cosmic voyagers during their extended journeys through space. The object's observed interactions with solar radiation, gravitational fields, and interplanetary magnetic environments provide invaluable scientific data about interstellar medium properties, directly benefiting ongoing research into cosmic evolution and galactic structure. Its successful arrival suggests either extraordinary durability of natural materials or perhaps possible artificial construction designed to withstand the harsh realities of long-duration interstellar travel. A scientific goldmine. The unprecedented arrival of 3I Atlas presents an extraordinary scientific goldmine, offering unique insights into the chemistry, physics, and material properties of objects originating beyond our solar system. NASA's James Webb Space Telescope has played an absolutely pivotal role in detecting previously unknown spectral lines within the object's complex electromagnetic emissions signature. Dr. Stefano Bagnullo leads international collaborative investigations that have successfully revealed unexpected complex organic molecules and exotic metallic compounds never before observed in natural celestial bodies. The accumulated observational data promises to shed revolutionary light on conditions prevalent in the early universe and the fundamental processes governing planetary system evolution throughout cosmic history. Intensive collaboration among international observatories has dramatically intensified, strategically leveraging multi-wavelength observations across the electromagnetic spectrum to capture the most complete scientific picture possible of 3I Atlas's true nature and composition. Scientists worldwide anticipate that these ongoing investigations will yield groundbreaking revelations capable of fundamentally reshaping humanity's understanding of the cosmos, interstellar chemistry, and the potential for artificial objects traveling between stellar systems. The scientific community recognizes this as a once-in-a-generation opportunity for paradigm-shifting discoveries. Unanswered questions. Despite extensive international study utilizing the world's most advanced astronomical instruments, there are still, numerous fundamental questions about 3I/Atlas that continue lingering without satisfactory explanations. Its documented orbital anomalies, mysterious surface composition, and those completely unexplained outgassing patterns consistently defy comprehensive scientific explanation using established astrophysical models. The persistent inability to detect conventional volatile substances typically associated with cometary objects fundamentally challenges existing theoretical frameworks and classification systems. Significant discrepancies between observed brightness variations and thermal emission patterns suggest complex surface interactions or perhaps concealed internal energy sources operating according to unknown principles. Leading astrophysicists like Dr. Sarah Seeger propose increasingly exotic alternative hypotheses, including the controversial possibility of artificial origin and extraterrestrial construction. The object's complete behavioral profile remains frustratingly elusive to researchers, continuously fueling heated ongoing debates within the scientific community, while at the same time, demanding expanded observational campaigns to decode its persistent enigmas. Each new measurement seems to raise additional questions rather than providing definitive answers, suggesting that 3I/Atlas may represent phenomena extending far beyond current scientific understanding. The mounting mysteries challenge fundamental assumptions about what constitutes natural cosmic objects. The alien question. The profound alien question has resurfaced with renewed scientific vigor as 3I Atlas continues exhibiting multiple characteristics that many researchers believe point definitively toward artificial origin rather than natural formation. Professor Avi Loeb, the prominent Harvard University astrophysicist and former chair of the astronomy department, argues compellingly that the object's unprecedented properties remain fundamentally inconsistent with any known natural explanations proposed by conventional astrophysics. He suggests that 3I Atlas could represent a genuine extraterrestrial probe deliberately sent to monitor or actively interact with our developing solar system civilization. This provocative and controversial assertion has sparked intense discussion within both rigorous scientific circles and broader public spheres, challenging established academic orthodoxies. Critics appropriately caution for maintaining rigorous evidence-based standards over speculative interpretations, but the continuously mounting observational anomalies increasingly pressure researchers to seriously consider dramatically expanded paradigms that accommodate the possibility of cosmic intelligence. The escalating debate highlights humanity's gradually shifting worldview as we potentially stand on the threshold of first contact with evidence of non-human intelligence. The implications of either confirming or definitively refuting the artificial hypothesis would fundamentally transform human civilization. Observing the visitor. Intensive observations from major global telescopes have dramatically intensified as 3I Atlas approaches its closest point to the Sun, offering unprecedented opportunities for detailed high-resolution imaging and comprehensive spectroscopic analysis. World-class astronomical facilities including the Very Large Telescope in Chile, NASA's Hubble and James Webb Space Telescopes, and extensive international survey networks have coordinated completely unprecedented observation campaigns. Dedicated research teams monitor measurable changes in brightness, trajectory, and emission patterns on a continuous daily basis, seeking any anomalous behaviors or structural modifications. The comprehensive data collection efforts specifically aim to capture transient phenomena including possible energy flares, potential communication signals, or unexpected structural alterations that might reveal the object's true nature. The global scientific community universally anticipates that these intensive coordinated observations could potentially provide definitive answers regarding the object's fundamental nature and ultimate origins, possibly marking a genuinely historic moment in humanity's ongoing search for extraterrestrial life and intelligence. The observational window represents our species' only opportunity to study this extraordinary visitor before it disappears forever into the cosmic void. Dawn of a new era. As humanity stands precariously on the brink of potentially transformative cosmic discoveries, the enigmatic presence of 3I Atlas fundamentally challenges long-held assumptions about our species' place within the vast universe. The object's increasingly complex behavioral patterns hint at the possible existence of a greater cosmic network and unknown intelligences actively operating throughout our galaxy. Leading scientists now seriously consider the revolutionary possibility that Earth and its inhabitants might have been systematically observed for millennia by advanced civilizations possessing technologies far exceeding human capabilities. This profound paradigm shift compels our species to completely re-evaluate our cosmic role, not as passive observers gazing outward at an empty universe, but as active participants within a dynamic, interconnected, and potentially populated cosmos. The ongoing revelations emerging from detailed study of 3I Atlas herald what may represent a completely new chapter in both cosmic understanding and human evolutionary development. Whether the object proves to be natural or artificial, its mere presence has already begun transforming how humanity perceives its cosmic significance and future destiny among the stars. The dawn of interstellar awareness has arguably already begun. The unprecedented insights from 3Y Atlas have ignited both excitement and genuine concern within the global scientific community. Whether this massive object represents natural phenomena or artificial technology, its passage through our solar system forces a profound reevaluation of cosmic possibilities. As intensive investigations continue, humanity waits on the cusp of possible contact and discovery. The universe may be far stranger and more populated than we ever imagined. Which aspect of this mystery fascinates you most? Share your thoughts below. If this cosmic investigation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible revelations.